Greetings, esteemed colleagues. It's a pleasure to be with you today again as we move further in the journey of English as a medium of instruction. We encounter today one of the most frequent tasks we face in the lecture, EMI classroom, or at the laboratory, which is describing how things work, whether we are looking at a chemical reaction or a line of code, or students need us to be bridge between complex science and the English language. Today, we will refine how we describe these processes to ensure our students aren't just watching but understanding. So, we will learn today how to describe scientific processes and experiments in the effective, appropriate English. As you have come to expect with me, I always guide you by mentioning the lesson objectives. Our roadmap today for this session is quite specific. By the end of this hour or this lesson, we will have mastered the use of advanced passive structures. We aren't just looking for correct English, but academic English. We will focus on logical sequencing and, most importantly, how to adapt these linguistic tools specifically for the fields of math, physics, chemistry, and computer science. Before we dive into the theory, let's reflect on our own practice as university teachers in the Faculty of Science. When you are standing at the whiteboard explaining a multi-step calculation or physics experiment, where do you feel the language gap most? Often we find ourselves focusing so hard on the technical steps that the explanation becomes secondary. Do you find your students get lost in the how or why? Well, I'd like us to look at this text together, which outlines the reality of English as a medium of instruction classroom. The core takeaway here is that scientific English is characterized by objectivity. In our native languages, we might use we or I frequently, but in English scientific discourse, the action is the star of the show. That is to say, not who did it, but the result of that action. Note the mention of precise and accessible language. This is the fine balance we must strike as lecturer. So let me read and explain the text. In science education, the ability to describe processes and experiments clearly is essential for effective teaching. Whether in chemistry laboratories, physics demonstrations, mathematical problem solving, or computer science algorithms. Teachers must guide students through sequences of actions and explain how results are obtained. In English medium instruction context, this task becomes more demanding, as teachers must carefully select language that is both precise and accessible. Scientific processes are typically characterized by sequence of stages, that is to say, by steps. Each stage represents a specific action or transformation that contributes to the final result. For example, in a chemistry experiment, substances are combined, reactions occur, and products are formed. In physics, measurements are taken, calculations are performed, and conclusions are drawn. Similarly, in mathematics and computer science, problems are solved through a series of logical steps or operations. One of the main linguistic features of process description is the use of passive structure, that is to say, the passive voice. In scientific discourse, the focus is often placed on the process itself rather than the person performing it. That is to say, it doesn't matter who did the process. What matters is the result of that process. As a result, sentences such as "the solution is heated" or "the data are analyzed" are preferred over active forms. That is to say, they are preferred over the active voice in grammar. This allows teachers to present information in a more objective and formal manner, which is typical of academic communication. Another important aspect is logical sequencing. Teachers must clearly indicate the order of steps using appropriate connectors. Without clear sequencing, students may struggle to follow the procedure or understand the relationship between different stages. Therefore, expressions such as "initially", "subsequently", and "finally" play as well a crucial role or an important role in structuring explanations. In English medium instruction classrooms, describing processes always requires attention to clarity and repetition. Students may not fully understand instructions or explanations if they are presented too quickly or in a complex language. Effective teachers often repeat key steps, rephrase explanations, and use visual supports to enhance comprehension. Additionally, they may ask students to describe the process themselves as a way of checking understanding. Ultimately, the ability to describe processes effectively is a key component of teaching in scientific fields. It supports not only the understanding of content, but also the development of students' academic language skills. For teachers working in an English medium instruction context, mastering this type of discourse is essential for improving both teaching quality and student learning outcomes. So, reflecting on that text, why is the passive voice the standard in science? You know why? It's because the person performing the experiment is usually irrelevant to the result, that is to say, unimportant. If a solution is heated to 100 degrees, it doesn't matter if a professor or student did it. The result is the same. This objectivity is what we are teaching our students through our language choice. Let's look at our power words today. In science, words like process and stage are our structural anchors. Observe is more than just see, it implies systemic watching, and measure implies precision. When we use these words, we are signaling to the students that we have moved from casual conversation into a scientific method. So now let's get into the mechanics, the passive voice formula. How is formulated the passive voice? It is the subject plus the verb to be in a specific tense, that is to say, either in the present, in the future, in the present perfect, plus the past participle of the verb. The past participle for regular verbs is the verb plus ed. However, for the irregular verbs, it is you can find it in the third column of the list of irregular verbs. So, speaking about passive voice role, it can be used to process focus, that is to say, it prioritizes the action over who did it, it keeps a formal tone, and it keeps our language objective, not subjective. Passive voice allows facts to stand independently of the observer. For example, in chemistry, the solution is heated in 100 degrees. In math, the values are substituted. Notice how this structure removes the human element. It makes the statement sound like a universal truth. As lecturers, using passive voice help us maintain formal academic atmosphere in the classroom. So, now let's speak about sequencing and modifiers. Logic in science is linear. Therefore, our language must be linear. The student should be guided through the process and through how the action are done. So, the sequence words like initially, subsequently, or in conclusion, or concluding, or finally are used to show the order of the steps. However, adverbs which are called modifiers, like carefully, correctly, automatically, they are used to describe how the action is done. Why are they called modifiers? Because they modify how the action is done, so they give extra details. So that is to say, they provide the technical precision that our subject demands. Okay, so here let's practice the transformation. If we have the active sentence, the student measures the temperature. When transforming it into a passive voice, we say the temperature is measured. Another example, the teacher explains the process. The process is explained. And finally, the program processes the data. And here we can say in passive voice, the data are processed. So, for example, rather than saying we take data and analyze it and it gets results, we can rephrase our language and speak professionally, like, for example, initially data are collected, subsequently they are analyzed, and finally a result is obtained. So you see the difference between the first and second sentence. The second one sounds more formal, academic, and professional. So, this is our final performance task. I want you to draft a short script. Imagine you are standing in front of second-year students. How do you guide them through a process? Use your sequence markers as signposts to tell them where you are in the experiment, and use the passive voice to keep the focus on the science. Okay? After that, we will now simulate a step-by-step explanation. As we listen to each other, let's provide feedback on 3 things. Ask yourself regarding the explanation or the process description you prepare to your students. Is it easy to follow? That is to say, does it include clarity? Regarding the structure, are the steps logical? And check the accuracy of your language. Is the passive voice used correctly and the sequence words and modifiers? So try to reflect on your prepared explanations, or you can do a peer-to-peer feedback with a colleague of yours. And remember that peer-to-peer work and feedbacks are where we grow most as English as a medium of instruction lecturers of different fields. So, to conclude our lesson today, mastering the description of processes is critical in English medium of instruction competence. It isn't just about knowing English, but it is about knowing how to teach science in English. Your homework is to prepare a 150 words formal explanation of a process for your specific field. Thank you for your time and your dedication to our students' success. And I am looking forward to receive your works either in our Telegram group or via my email. See you in the next session.